Hello everyone, thank you very much for your time and presence. It is our privilege to have you join today. My name is Zishan. I take care of digital marketing at Utthunga. We welcome everyone to the webinar Ethernet-APL, Ethernet Connectivity for Field Devices. In today's webinar, we will share information on Ethernet-APL and its scalability. We will also discuss about how one can migrate to APL. Before we get started, I would like to take a couple of minutes to introduce Utthunga. Next slide. We are a product engineering and industrial solutions company. For over 13 years, we have partnered closely with industrial OEMs to build products and solutions from concept all the way through the life cycle of the product. Our engineers have added digital layers to mechanical, non-digital field devices, built configuration calibration software, highly sophisticated data integration, visualization and analytics solutions, provided consultation and services on industrial security and quality engineering. We offer services in application development, embedded services, IoT, and verification and validation. Our services are targeted to OEMs and end industries in process, factory, and power domain. We follow a strict and secure development lifecycle for all our projects. Next slide. Next slide. These are the few industrial consortiums we closely work with on connectivity and protocols. Industrial connectivity is a foundation for Industry 4.0, and that's how we started as a company about 13 years ago. That is connecting field devices and assets to hardware and software systems up in the value chain. Our association with this consortium is rooted in our commitment to help our customers build interoperable industrial systems. Next slide. With that, I would like to introduce the speaker for today. Jegajith is an electronics and embedded system expert with over 15 years of experience in managing projects and product development. He has tremendous expertise in development of IoT devices, firmware, and other embedded systems. His experience in researching, evaluating, and synthesizing technical information to design complex systems, electronics, firmware, and software. Just a quick housekeeping point before we get started. The duration of webinar is 60 minutes. We will utilize the last 10 minutes for Q&A segment. Please send in your questions using the Q&A icon on your left-hand side of your screen. The presentation slides and the link of the webinar recording will be emailed to you post-webinar. Request for you to click on the full screen icon on the left-hand side of your screen to get a good view of the slides. Before I hand it over to Jegajith, a quick poll for 30 seconds. Request the attendees to please select your answers. Thank you for your answers. We have got a mixed response, and so many people are having a little bit information about APL and SPE. So that's without further delay, I would like to hand it over to Mr. Jegajith to continue with the presentation.
Thank you, Jishan, for the introduction. So I'm Jegajith, and welcome everyone for this webinar. So today we are going to talk about introduction about on the process industry in terms of a communication standard, and we have a quick understanding about the automation pyramid, typically how the field devices are connecting to the control system as well as a supervisory system and as well as cloud. And we are going to discuss something about the process automation communication standard and Ethernet comparison and OSI model. Then Ethernet-APL advanced physical layer, a little more details about that, and a few examples about our network architecture. And we are covering how to migrate to APL because this is a physical layer changes. It's required some certain kind of design requirement and as well as some kind of a planning. So how we can migrate to advanced physical layer technology. Then we'll conclude. So, quick introduction. If you see our existing Ethernet communication protocol or any other field device communication, which are not completely made to fit for in any industry 4.0 or compatible, like the field device to the cloud, which is not completely into reality. Like if you see the system, like we may need a gateway, we may need other cloud aspects, and which is going in a layered architecture. So by implementing this Ethernet-APL, it just truly demonstrate the OT layer to become an active stakeholder by connecting to the cloud. So one physical medium from sensor to cloud, that is what exactly we are going to talk about, advanced physical layer here. So let's look into the automation pyramid, what exactly and how the current system is working. So it's most of the people are aware about it, but still I would like to go through a little bit in detail to understand and explain about the architecture of how an automation pyramid is working. Typically a representation of a factory here. So we have 4 level of system, or I would say like a 5 level of architecture or pyramid, where level 0 represents the production process, where all the sensors and actuators or any controlling element which is in the shop floor is sitting on the level 0 side. And sensing and manipulating, which is mostly on the data connectivity, integration, and the control system aspects, whatever the sensors and actuators are coming, which is connecting to this kind of PLC, HMI, or any other control system aspects, which is coming into the level 1 stage. The next is level 2, which is monitoring and supervising, which is a SCADA-based system that's typically focused on mostly on the operation management, device data integration, as well as in factory various the operations related to the production related aspects, and everything is managed in the level 2 stage. And the level 3 is coming manufacturing operation management, which is on the MES system. It's more into the business domain applications, as well as the various planning aspects is coming on to the level 3. Level 4 is ERP, where business planning and logistics. That's typically level 4 is deciding up to the shop floor level what kind of shift and how we are transforming all these factory operations and make it productive. So those things are captured on the level 4. And finally, the data is going to push to the cloud for various data analytics and aspects. So this is the typical aspects, and cybersecurity is something which we have to cover in all set of this layer, because anything connected to the cloud or anything connected to the security, anything connected to the public, we need to ensure the security. So all layer ensuring security is the one key element in the recent trends, and we are going to talk a little bit about when it is coming to the APL, because we are connecting all this level 0 sensors to the cloud, means that the penetration chance to the lower level layer is the more sensitive or more vulnerable to the security aspects. So we'll go in detail in the coming slide. So I would like to talk about specifically HART protocol, which is pioneering the industry past 60 years or more than that. So why specifically talking about HART? Because most of the process automation highly adapted this technology in all kind of communication, in terms of sensors communication, actuators communication. So a little bit know about HART. HART basically a 4 to 20 milliampere loop powered system. So the loop current will vary from 4 milliampere to 20 milliampere. So this loop current can be encoded to a control signal. On top of that, we are transmitting a set of digital value in a phase shift keying manner. So each set of 0 and 1 is representing a certain frequency, and these frequencies are transmitted over this current loop. So when we are transmitting this data, this loop current is not getting disturbed. It's maintained the same current, whatever it is transmitting towards a loop. So this is the way process automation, most of the digital valve or any control valve or any other sensors, which is transmitting the data from field to the nearest PLC or control system, has been working. Now a little bit more into the HART. So I already discussed that HART is again a digital and analog combination. So HART, how the data is transmitted and packetized. So there are various commands which is working on HART. So there are a set of commands like universal command and common practice commands as well as device specific commands. So universal command is something which is part of the specification, and common practice also part of the specification. Universal command is mostly related to primary variable related functions, and common practice is something related to the selection of up to 4 dynamic variables and damping time constants, trim the PV value. PV value is something like that, the primary value, secondary value. There are different parameters in the HART side. And device specific command is something like that, which the customer can select what kind of commands or what kind of device specific related things. Say example, if I'm talking about a temperature sensor, I can say the temperature setting, I'm going to set these kind of commands. So that is what it is coming into the device specific commands. So HART is completely packed with the various set of commands. So let's look into the HART architecture, how HART architecture is working. So here I'm just giving an example about a SCADA DCS application, which is connected to Ethernet IP and connected with various IO systems through HART. And there are HART devices which is in the field, and we are talking about HART IP, and that is also with the multiplexer. We are connecting to different devices, and one side it is coming on the wireless HART side, where instead of having this 4 to 20 milliampere wired interfaces, there is a 2.4 gigahertz wireless connectivity is established between this wireless HART mesh network. So this is a revolution, or which is predominantly used in most of the industrial automation or the process automation side. So let's look into the today's topic, like APL, Advanced Physical Layer Ethernet. So advanced physical layer is something like that new physical layer concept, which is going to replace our existing Ethernet physical layer. So existing Ethernet is again an RJ45 connector that is getting replaced by a single pair of connectors, which will go in detail how this is going to do it. But the why Ethernet is required for industrial automation, because one major aspect is that internet and as well as Ethernet is part of our daily life. So this by considering various aspects like safety of people and environmental aspects, deployment and connectivity solutions, and as well as the business benefit that the new revolution of APL has derived. So let's look into the Ethernet general comparison between other devices. Like it's an industry revolution when we are talking about that. It started with the pneumatics, where we can transmit only one value, which is over the air. By setting up a certain pressure, we can operate some valve, or we can operate some certain actuations. We can do it. Then the next revolution has come into 4 to 20 milliampere side. Of course, 4 to 20 milliampere is again we can transmit only one value. 4 milliampere can be used to represent a valve 0% opening, and 20 milliampere we can represent to open a valve 100% opening. Again, it's a analog communication aspects. But when you see the local access to data, it is not possible because it's an analog thing, and which we may need to have an analog to digital conversion and convert the data to the next level. Then when you come to HART devices, it's as I discussed in my previous slide, HART devices comprise both 4 to 20 milliampere as well as a HART protocol, which we have discussed about the digital values. So one device which we can use it to power up the devices in field, and as well as we can transmit both analog and serial data, where we don't have any limit of number of data. So all this data can be encoded into various commands like a common practice and universal commands, and as well as custom device specific commands. So when we are talking about hard devices, when we are connecting to a local data access, yes, it's required some gateway, because this required a special modem. That modem connected with a gateway can be pushed this data, and since it has a mixed signal, the gateway will transfer the data to a digital data, and that can push to a local data access. When we talk about remote data access, definitely we require a gateway, because the gateway will enable the Ethernet or the network layer connectivity here. So next is field bus. We are talking the field bus is something again a completely digital signal, that is again a serial digital interfaces. So here also we can transmit a number of values, and the local data access, of course, is a differential pair of a digital signal, so that can can be accessed locally. But when we are talking about remote access data, like pushing the data to the cloud or anything on any data analytics aspects on the computing aspects, that is also required a gateway. But when we talk about Ethernet in all layer in terms of technology, media, measurement, local access to data, and remote access data, Ethernet everything is integrated and it's giving a flexibility to transmit end values. So that's the reason Ethernet is pretty much stable in the industrial automation side, and various other protocols, industrial Ethernet protocols are developed on top of this. So now today we are going to talk about advanced physical layer. So I would like to discuss about the various organizations in this working group, and Utthunga as a company is actively participating in Philcom Group, ODVA, and OPC Foundation, as well as Profinet and Profibus. So where the APL now advanced physical layer, this is not yet launched to the market, but there are different progress. It's happened 2015. It's the first concept as described, and 2018 official APL project has started. And in between that, 5 chip availability is soon. We are waiting for the physical layer chips, but IEEE standards have been approved. Now onwards, APL we can say 10 base T1L. So once the particular APL official specification is released, and as well as we have the physical layer, definitely we'll have a detailed session in coming webinar sessions. So let's look into the OSI structure, where exactly the APL is going to make some changes. So this particular OSI model is, I think everyone is familiar with this model. So here we are going to talk about application layer. So if you see in the bottom side, the physical layer, we have a various Ethernet thing like a fast Ethernet, gigabit Ethernet, or wireless LAN, or whatever it is coming on the Ethernet format. It's making some physical layer changes, and Rust layers are untouched. Like when we talk about TCP/IP, UDP, or IP, or when industrial Ethernet, like time sensitive network for the fast communication or critical communication. So with adapting APL, there is no change in the physical layer to the application layer. Everything remains same. And with APL, we can get all features of Ethernet-IP or HART IP, OPCA, Profinet, and all the general Ethernet protocols. So APL is again based on 10 base T1L, which we have discussed, and that is again IEEE 802.3 CG with an additional provision for process industries. And Ethernet again, APL relies on the 10 megabits full duplex communication transport by a twisted pair cable, and it doesn't require any kind of a polarity matching. And again, this will support a trunk and the spur topology, which is widely utilized in the process industries when you're talking about the field bus topologies. Then the maximum distance this can cover up to 1,000 meters for zone 1 division 2, because this APL is coming with intrinsic safety protection aspects. So we'll do a detailed discussion on that. So when we are talking about intrinsic safety, when it is coming to a hazardous area, 200 meter is the maximum length on zone 0 division 1, which is an explosive area. So this is once APL is realized, you can see from our field device to the operation layer, everywhere we are talking about one technology called Ethernet. So it's offering a 10 megabits per second speed, megabits per second, and distance of 1,000 meter, and the energy again field device supply, which means that power over data is available, and its intrinsic safe attributes are considered, and standard is 10 base G1L, and 2-wire connection is easy. So 2-wire connection, what happened when we are going to verify only 2-wire electrical specification. So that will reduce our design overhead related to the intrinsic safety aspects. And when it talks about the power, it can deliver up to 500 milliwatt in zone 0 application, and 36 milliwatt up to when we compare about 4 to 20 milliampere, it can deliver 36 milliwatt, and APL is giving 500 milliwatt, which is comparatively a higher value. And with that, definitely the low power devices or the data line the powering the devices through data, which is practically possible. So this is a quick comparison about the communication technology. So this is based on a single pair cable, so 420 milliampere and field bus. But when we talk about our standard Ethernet, it is not single pair cable, but 10 base T1 is single pair. And communication aspects, the HART offers 1.2 kilobits per half duplex communication, but field bus is 31.25 half duplex. But when you talk about Ethernet standard 100 megabits per seconds full duplex, here 10 megabits per second full duplex. The cable wise, 4 to 20 million don't have any cable specification, but at least any electrical conductor with a shielded capacity can be travel those 4 to 20 milliampere signal. Field bus is type A standard as per that, and Ethernet is Cat 5 or 6, depends on the network topology. And Ethernet is type A cable, which is similar like a field bus. A twisted pair cable can be used. And the trunk length, which I am talking about, the maximum distance is 700 meter in case of field bus, but in Ethernet it is coming 100 meter, and Ethernet APL, which is 1000 meter. Spur length is basically on the safety aspects. When the field switch to the devices, it is 120 meter. When it is come to the Ethernet APL, it is 200 meter. So screw type connector, which is flexible for people to use it, that is can be used in case of 420 milliampere field bus, even Ethernet APL as well as Ethernet also. But Ethernet, it depends on certain conditions, like up to 1 GHz and certified on the zone 1. Polarity independence is not possible in case of 420 milliampere, and it's not applicable in case of standard Ethernet. But field bus, it is possible, but it depends on the design. But advanced physical layer, yes, polarity independence is possible. Intrinsic safety option is applicable to every system, but again depends on the design and the complexity. So if you compare 4 to 20 milliampere devices, because the maximum power with that excitation voltage, we need to calculate how much energy it is dissipating to the field. When it is coming to intrinsic safety, it's again low signaling of electronics components. So any spark or any hot surfaces or any flammable things which is in contact with the vapor, gases, or debris or dust or chemicals, which can create an explosion. So when we are designing any electronics or any other the process industrial electrical aspects on the hazardous area, which has to be extremely careful when we are designing the electronics, because that electronics should not dissipate any energy which will create this kind of spark or an ignition which can cause an explosion. So we'll talk in detail in the coming session. So before that, I would like to give an idea about what exactly this zone. So with a very simple pictorial representation here. So in this figure, you can see that a gasoline tank, which we call it as a zone 0, where 100% chances of the flammable things are present. Where inside the gas tank there could be a fumes, or it could be the gasoline itself is present, which is close to the tank area. We can say that zone 1, where it's a likely present the flammable materials, and which is far away or maybe not very far, which is very close to zone 1. We can call it as zone 2, where are likely very less the things are present. So that is one aspect here. So let me move to the next slide, and let's talk about various network example of Ethernet APL. So we already gone through that, what exactly the zone and what kind of things it is. I mean, in terms of zone 1 and zone 2, what exactly it is, we already discussed. So if you see, we are using a standard Ethernet system to connect to the various engineering workstations, control stations, asset management system, and IoT optimization. So this is the typical infrastructure this is typical infrastructure we are talking when we are discussing about a process automation plant, where we are operating a control system which is in a safer area, and we have a various the controlling element as well as other sensor device which is in the field. So what kind of topology it will support. So I don't want to go in detail about the network topology because everyone's are aware about the standard Ethernet topology. So Ethernet-APL support all network topology which is standard, and on top of that, it support our the famous bus spur topology, basically trunk spur topology, which is widely used in the field bus foundation. So speed of Ethernet types, I just want to compare because I already gone through the in detail about this kind of thing, but still I would like to quick understanding, because 10 base T1L we'll get up to 1000-meter distance, and where our data rate is 10 megabits per second. And if you see our 1 gigabits per second, where a 10 base T1L, it's not that up to that level in terms of this, in terms of our the cable length. So Ethernet-APL physical layer again able to support all kind of protocol like Ethernet-AP, HART IP, OPC, Profinet, or any other high-level protocol it can support without changing anything on the software side. Only changes is something that we need to change the physical layer aspects. So we'll talk about the APL terminology, and because we already discussed about the one block diagram, but I would like to go a little more detail about that. So these are some of the infrastructure and components part of advanced physical layer, where we have a power switches, and there is a trunk which is 1000-meter. We can transmit the data, and there is a field switch which is in the field. So field again, the trunk carry a high power and a very good thickness trunk to the field switches, and from field switch we got as a spur, which is a 200 meter. So this blue line represent the intrinsic safe area, which is in the field devices. So this is the typical infrastructure and components for any APL terminology. From their power switches, it will power the devices to the trunk devices, which is the field devices. From there, we can use a standard Ethernet to connect to the OT system. So we'll look into the more topology aspects. So when we talk about star topology, this is the very famous topology in Ethernet side. So you can see various color code here, which is a green color is a facility internet, and the orange color is an increased safety, which is a zone 2, zone 1, and blue version is basically APL intrinsic safety aspects. So in this case, you can see that APL switch is powered by an auxiliary power, which is powered from an external source, and from there field devices are powered by on bus. So again, these field devices, whatever it is on the increased safety area, which is on zone 2 or zone 1, and other devices are also self-powered. But only thing is that this is designed for intrinsic safety aspects, considering the various power element to ensure that it will not create any explosion in the status area. So this is for long field cabling. When we are talking about pharma industry or any other the bigger industry or a water treatment plant, or which is a large field of operation. It's not like a typical industrial factory environment, which may be something an open field where we need to distribute the power and as well as the data. So this is something which we are talking about, where from engineering, asset management on the OT layer, there is an APL switch, power switch, which will take an auxiliary power and it will distribute to the power to field devices. So field devices can be distributed to multiple places. So this particular distribution this is a trunk connection basically. This trunk connection, one trunk connection to another trunk connection, we can go up to 1000 meter. From here onwards, we can go up to again 1000 meter. So from there, you can see two topology here, where increased safety, which is in zone 1 or zone 2, and we have an explosive area where we are distributed the intrinsically safety component for long field cabling. So this is a typical topology or a connection diagram for any APL devices when you are going for a long field cabling. So this is an automation pyramid, which I discussed on at the very beginning itself, where we are combining all the aspects like APL field switches, which I already discussed that for long-term cabling, with an intrinsic safety zone and a safe area, and auxiliary power, which is on the field level communication side. And OT side, if you see, it's all standard Ethernet connection, And standard Ethernet connection can be connected with the cloud aspects here itself, and the field device is also connecting to the cloud. So this will actually reduce our all kind of overhead related to the in terms of field level communication. So in the typical architecture side, there is a very limited access to connect these field switches to the cloud aspects or the gateway aspects here. So from field device to the cloud, we are talking about one standard Ethernet. And there is an opportunity where we can connect these devices directly to the cloud also by considering all the security aspects. So this is something on prototyping and engineering various aspects. When you are doing for definitely on APL side, network planning is one key element which you already discussed about the different protocols. And the design of typical loops is one aspect. And access to all details stored in the instrument, such as device driver descriptions, manual certification, and instrumentation parameters and configuration is some other thing which we can do it. And instrument diagnostics during operation is one other aspect. So this is APL attributes. This is already we have discussed about that the standards based on IEEE 803 3CD 2019, which we can sell the 10 base T1L. And the power supply output, again, that is based on a single pair Ethernet, and power supply output is up to 60 watt on APL trunk. And of course, it's a switch network. Redundant cable and switches is optional, like HSR, PRP kind of a protocol can be an optional thing. Reference cable is IEC 611582 type A for intrinsic safety. Cable cross section will do in detail one dedicated slide I have prepared for that. And maximum trunk length, which can be 1000 meter into zone 1 and division 2, and spur length, which is on the increased safety or hazardous area distribution, is 200 meter into zone 0 division 1. And the communication speed is 10 megabits per second, so full duplex communication. Hazardous area protection, yes, it has an hazardous area protection aspects also considered. So scalability and reliability aspects. So we already discussed about the robustness and high reliable operation of Ethernet, which is that is 10 base. It's based on 10 base to T1L single pair Ethernet. And operation of managed system network architecture, that's high speed industrial communication, long distance, ensure the reliable communication, because in most of the industrial automation network, people will use a managed switch to maintain and control the traffic. And the power budget of up to 60 watt and data traffic up to 10 megabits per seconds, which is for excellent scalability with regards to number of Ethernet-APL switches and instruments that are connected. And some of the features on Ethernet-APL transport layer that is as similar like our Ethernet thing is automatic neighborhood detection, and that's again depends on the switch and with the simple device exchange, and multiple communication path that can be run in parallel. Again, this also we required a certain level of network architecture, how we can ensure redundancy in the network, like in case if the cable got disconnected, we can have an alternative path to reach to the field devices or the field switches. And superior the plant availability aspects, ring redundancy or resiliency concept at the network layer reroutes communication signal in case of Ethernet-APL truck segment is failed. So handling and installation in terms of connector, as we discussed, we no need to depend on the typical RJ45 sophisticated connector here. We can work with any kind of spring clamp terminals or screw type terminals or typical M8 and M12 connectors. So the field, the instrumentation engineers or the technicians to handling the APL is APL based connectors is very easy, and it's not required any kind of a special connectors or a single screwdriver is enough to remove the connections and put it back. So again, it can support the field bus cable type A, that is as per the standard, or we can go with AWG class wire, which is 20 to 14 wiring cross section of 0.324 to 2.5 millimeter square. So this provides an easy migration and as well as the existing field bus installation, which is a legacy devices, and again including the support of intrinsic safety and plus on top of that the polarity independence. And, so with all these things, it reduces field wiring errors and as well as it make the installation much easier compared to any other field network. Now, migrating to APL, what kind of thing we have to follow? So, first we should have a network architecture, because why I say network architecture, because we need to segregate whether this particular devices or the end devices is going to work in the intrinsic safety area or a non-intrinsic safety area. Based on that, we should have a network architecture to plan the power profile and as well as various other switching aspects. And in case if you want to give a redundancy in terms of device connectivity or the data aspects, we need to plan the network architecture and selecting an APL 5. So as of now, APL the 5 are not released to the market, but definitely there will be a couple of options of physical layer of advanced physical layer devices. Once it has released, the selection of APL is a crucial point here. Then we need to understand the various interfaces with the microcontroller or microprocessor. Then since the APL is designed for intrinsic, it has designed for intrinsic safety and process automation. Most of the process automation demands intrinsic safety design aspects. So in the IS design is one aspect, because even though our communication standard is providing the intrinsic safety standard, still we need to do the power calculation and all the documentation, design validation for intrinsic safety in terms of our device and as well as application. Then of course application firmware development onto the device or the system by considering the security aspects, because one concern or one topic which I would like to discuss in detail, because when we are enabling Ethernet to the field devices, we are giving still we are giving an access to the connectivity aspects compared to the legacy devices 4 to 20 milliampere or any other devices. Reaching to the field devices is really tough, because there are many isolations and there are many barriers. So in this case, since Ethernet is reachable from cloud to the field devices, security is the biggest concerns. So it is better to explore all the available security features to ensure our field devices are securely connected to the cloud or securely connected to the nearest gateway or the first level of isolation. So we can implement various security aspects like the TLS transport layer security, a secure socket, or a trusted platform module, or validation before the production. All this aspect has to do in terms of functional testing, and later we can take to productions. So Utthunga as a company, what we can offer on the advanced physical layer, the migration plan is something like that. We can offer field bus to APL migration or any devices which is a legacy devices and it has to adapt to the advanced physical layer. We can help you to work with our customers, and device engineering with APL, which is a complete package. We can work with advanced physical layer based complete system, or it's included firmware, hardware, and complete product engineering, considering all other aspects of intrinsic safety. Or intrinsic safe design alone itself is a service offering, and APL application on top of that, because being a protocol expert company, we have expertise in Ethernet IP, OPC UA, Profinet, HART IP. So these applications can be integrated part of our device engineering and IoT and network architecture, because when we talk about APL, various the spur trunk topology as well as different kind of network architecture is something which we can provide. And the way we can associate it could be a turnkey based business model or offshore design model or in a consulting mode, or we can utilize our engineers to support you on this offering side, or it could be an outcome based design model also. So these are my reference I have taken. So with this, I am concluding this webinar. I am open for questions.
Thank you, Jagjeet. And I request all the attendees to please drop in your questions in the Q&A box there on the left-hand side of the screen. And Jagjeet, we have also received a few questions. You can start answering them if you like.
Yeah, so there are the many questions we have received. One question is something like that: how factory automation is planning to take advantage of Ethernet APL? It's a very good question because the APL is it's the one advantage is something like that. When we are migrating to APL, definitely we can use this connector. Like if you see if you are using a standard Ethernet connector, once you migrate into single pair Ethernet concept, connector is the biggest advantage. And second thing is the distance, because the total distance where we can route these the cables are almost 1,000 meters. So that is one advantage. We can take it for factory automation aspects. And since we are converting this connectivity aspect to single pair Ethernet, there is no change on the application side. So how field bus protocol is going to adapt OSI models such as HART IP, any other field bus protocol started supporting this model? So this question I'm not clear. So I assume that see any industrial Ethernet protocol which support OSI model only. And in some exceptional cases, like when we talk about EtherCAT, so EtherCAT again, it's using only the physical layer and it's directly jumping to the application layer. So and even any industrial protocol also, they have made their own flavors in terms of the OSI structure. So one question I have received from why whether Modbus TCP/IP or other devices can still use APL. Of course, yes, we can use advanced physical layer for any industrial protocol. That's what I mentioned in my first, I think somewhere in the first or second slide, that our application architecture remains same and only it is going to be a physical layer changes. So there is no need to change anything on the physical application side aspects. Only the device side physical layer aspect has to change. So definitely AP will support all kind of TCP/IP or any other industrial protocols. So one question I have received: what are the maintenance consideration for Ethernet APL cabling as well as the field devices? See, maintenance aspect has very much minimized in case of single pair Ethernet or advanced physical layer, because here we are going to handle a single pair cable and the connectors again we can choose various connectors like M12, M14 connectors, or a general screw terminal connector can be used. So the technically speaking, in terms of field level maintenance and as well as the man errors, it is comparatively very much less when you compare our standard Ethernet. Will there be 4 to 20 milliampere interface on APL? Very uh, tough question to answer at this point, because advanced physical layer chip, we need to see the specification to understand that. So far my understanding, this has a very good noise immunity. So this 4 to 20 milliampere noise or any other noise, it can withstand in the field. So one question is, can you talk a little about certification, how device vendor get their products certified? So product certification has a different aspects. On APL compatibility side, I believe the APL chip what is available in the market, those things can be pre-certified. So we can use those chips for this kind of things. When we are talking about in terms of a product certification, definitely we have to go through that process, and that's again depends on the various certification standard. When you're talking about intrinsic safety or ethics, it has to go through that process. So we can provide such kind of services to our customer. One more question. As a complete new person without much background to APL, basically APL support field devices communication via Ethernet. And then and that can happen either on normal Ethernet connectors like RJ45, but also on two-wire field wires. See, I think this question again a bit confusing for me, but my answer for this question is something like that. Advanced physical layer is something like the new physical layer concept where you are getting all Ethernet features on a two-wire cable, basically a single pair cable. So that's not going to make any big impact in the application layer, that is for sure. But definitely it is replacing the RJ45 connector, which is a typical our Ethernet connector. So that is. One question is, who are the likely customer planning to deploy Ethernet-APL? Practically, what is the biggest hurdle to deploy Ethernet-APL or move from legacy to Ethernet-APL? Very good questions from one of the audience. So this mostly when we are talking about the process industry, the people who generally use 4 to 20 milliampere, the power devices or the field devices, people, they they generally use uh, the they generally use these kind of legacy devices. When we convert into APL, we are offering a single pair Ethernet connectivity. So with intrinsic safety aspects. So with intrinsic safety, if you want to have a bunch of data control, definitely those people are going to change. And the biggest hurdle to deploy Ethernet APL or something like that, definitely there is a hardware or electronics change which we need to take care. That is aspects, I would say, the biggest hurdle. So the device engineering aspects by replacing the physical layer is going to be a little challenging thing, but it's not difficult to achieve it. Elaborate the topology maximum distance. I think I covered in my presentation with my network issue or something like that. Some audience were not able to listen that. So apology for that. So the topology wise, it supports all topology related to Ethernet. Like our standard Ethernet offers various ring star topology. And on top of that, Fieldbus offers our famous trunk and spur topology. So that also it supports. So when we talk about the distance, single pair Ethernet is offering 1,000-meter distance. So that's a maximum distance we can get it from a single pair Ethernet. And on top of that, when we are distributing that to a safety area, which is a zone 0 or a zone 1 aspect as a spur connection with the power switches, in that case, as the maximum distance we can get it 200 meters. So one more question is something, does all field devices are compatible to connect with APL? It's again very subjective because the field devices should have an APL option to connect with an APL switch or an APL network devices. If the device is already migrated to APL, definitely it can connect that. But any devices which is a legacy devices with a very minimum changes on the connectivity or the communication aspects, we can migrate it to any APL devices. So I covered most of the questions here. If you have any other questions, you can raise to us.
Thank you, Jagjeet, and thank you, the attendees, for sending out the questions first and your participation. There are a few questions we were not able to answer, but due to the time constraint, we should answer them via email soon. If you have any other further questions, please email to us at contact@utthunga.com. I repeat, contact@utthunga.com. Before we move on, let's have a poll for 30 seconds. I request the attendees to please select your answers. Thank you for your answers. And there's a mixed response again. Most of the people have also selected for, they have a requirement for intrinsic safety for the field devices. Although the Ethernet APL specification is not released yet, Utthunga as a product engineering company has started exploring and observing the technological changes that Ethernet APL is going to bring to our customers. Definitely, we will be the early adopters of this technology. Next slide. With that, we have come to an end of our session today. Thank you everyone for your participation in this webinar. We hope this session has enhanced knowledge on Ethernet APL. Utthunga as product engineering company, we can help you build products and solutions from concept all the way to the life cycle of the product. If you have any other queries, please feel free to reach out to us at contact@utthunga.com. I repeat, contact@utthunga.com. Do check out our YouTube channel. Watch our previous webinars on other topics. Just search for Utthunga in the YouTube search bar. The first thing you can find us is don't forget to subscribe to the channel. Finally, do follow us on LinkedIn, where we share all the latest information and our ongoing activities there. Thank you everyone and stay safe.